extreme rainfall events in Brazil.
So first off, I'd like to thank my mentor, Dr. Eleanor Martin, for supporting me in this project, as this project wouldn't be possible without her help. So I'm going to be investigating the probability of compounding heat wave and extreme rainfall events in Brazil. So heat waves, as you probably know, typically bring extreme impacts across the globe. In fact, one of the leading causes of weather-related deaths throughout the world is due to heat waves. However, an indirect impact that isn't commonly associated with heat waves is a possibility of extreme rainfall happening shortly after heat wave termination, as this has been a common occurrence in numerous areas of the world, as you could probably see in places like Europe, Japan, as well as the northeastern portion of the United States. Those areas typically have a much higher probability of experiencing extreme rainfall after a heat wave ends, where the percentage hovers right around a 30% chance of extreme rainfall happening, which is much higher compared to their daily average when it comes to extreme rainfall. However, this event hasn't been thoroughly investigated in Brazil and how it could pose a significant threat to the country, as Brazil's urban environment and infrastructure, where the majority of the population lives, is very vulnerable to extreme weather events such as flooding. Since a lot of these cities in Brazil were built over floodplains, so that makes them a large portion of the population extremely vulnerable to extreme rainfall events and flooding. And 74% of deaths related to natural disasters in Brazil have been attributed to extreme rainfall events inducing flooding and mudslides. So it's very important that we really identify any sort of trend when it comes to the possibility of extreme rainfall happening shortly after heat waves. And due to climate change, the frequency of heat waves in Brazil have been increasing, which raises a concern that along with heat waves, we could see more extreme rainfall events increase in Brazil as time goes on. And as you could see with the graphs, for Sao Paulo, Brazil, we see that the trend for heat waves have been increasing over the past several decades, especially in the past 3 decades. And then for Manaus, Brazil, we also see that trend occur, where the frequency of heat waves have been increasing by a lot over the past few decades. Therefore, the objective of this project is to investigate the probability of extreme rainfall events happening shortly after a heat wave terminates, to better predict the long-term, more localized effects of climate change in Brazil and how it could affect a country directly based on how vulnerable each city is. So the way I'll be doing this is by taking a look at the daily maximum temperatures for Brazil between 1961 and 2020, as the data I will be pulling from, it comes from over 1,000 different weather stations throughout the country. I'll also be using daily precipitation data between 1961 and 2020. And in terms of the criteria I'll be using when it comes to defining what a heat wave is, there isn't really a set definition, but the criteria that many studies use is typically using the 90th percentile threshold, where the temperature needs to be above the 90th percentile for at least 3 consecutive days for it to be considered a heat wave. And then when it comes to extreme rainfall, event would be considered an extreme rainfall event if the daily precipitation exceeds the 95th percentile. And for it to be associated with the heat waves, it would need to happen within 48 hours after the last day of the heat wave. So some of the the places I'll take a look at 5 different cities in Brazil, which encompass 5 different regions, because of course every region in Brazil is very different when it comes to the climate. So a city that might experience a compounding extreme rainfall right after a heat wave might not necessarily see that in another city where the climate is very different. So we're going to be taking a look at that at 5 different regions, and Python code will be used to extract the events that meet the heat wave and extreme rainfall criteria. And here's an example of this. So this is the temperature and precipitation data for Sao Paulo, Brazil, where the graphs would detect where the heat waves are detected, where the temperature is above the 90th percentile, and where the extreme rainfall is above the 95th percentile. And as you can see, there were several instances where heat waves were detected during the year 2011. There wasn't really any compounding effect in this specific year, but in many other instances for Sao Paulo, we did see evidence of extreme rainfall happening shortly after a heat wave occurs. So in terms of the results for Sao Paulo, Brazil, so the average annual number of heat waves per year is hovering around 4.6 of 5 heat waves per year. And of course, that has been increasing over the past several decades. And then the daily climatological average of extreme rainfall occurring in any given day is around 4%, but the probability of that happening after a heat wave raises all the way up to a 23% chance. So there's nearly you're nearly 6 times more likely to experience an extreme rainfall event right after a heat wave compared to average for Sao Paulo, Brazil, which really gives a good indication that heavy rainfall is very prevalent in Brazil right after a heat wave. And for another city in Manaus, Brazil, which is a little bit further northward and a little bit further westward, the average annual amount of heat waves is very similar to what we saw in Sao Paulo, Brazil, which is around 4.5. However, we didn't see really any sort of probability increase after heat wave termination compared to the climatological average, where it pretty much remained at 5%, whether it was right after a heat wave or just compared to the average. So there doesn't seem to be a trend when it comes to extreme rainfall happening after a heat wave. So northern Brazil receives mostly stable temperatures throughout the year. As you could clearly see, it's while southern Brazil varies more significantly when it comes to temperature throughout the different seasons. And as you probably noticed with the mean annual heat waves, most of the heat waves tend to occur right around the southeastern portion of the country, where the temperature is a bit more variable between seasons, which could indicate that the areas that have a little bit more variation when it comes to temperature between seasons have a higher possibility of experiencing the compounding heat wave and extreme rainfall events. And due to the fact that these areas experience more heat waves, there could be that possibility that the southern portion of the country would also experience more extreme rainfall events shortly after a heat wave terminates, and especially as heat waves continue to increase over the next several years. So for the summary, Sao Paulo, Brazil is 5.75 times more likely compared to average to receive an extreme rainfall event after a heat wave terminates, and then extreme rainfall events are likely to increase for Sao Paulo as heat wave frequency increases, and then heat wave terminations also have no noticeable impact in terms of the probability of extreme rainfall in Manaus, Brazil, as it seems like in the areas a little bit further northward with less temperature variation, there's less likely of a shot you're going to experience the phenomenon where extreme rainfall would occur after heat wave terminations. And then temperate regions of Brazil are significantly more likely to receive heat waves compounding extreme rainfall events. So it's definitely important for the areas in southern Brazil to pay attention to that trend where the possibility of extreme rainfall is far more likely in that area of the country. And that's it.
Do you have any questions?
I'm curious on how you're defining like after a heat wave. So like if you said it's extreme rainfall like after, is that like a week or like a few days? Like do you have like a cutoff for that?
The question for online.
So your question was if there's extreme rainfall right after heat waves and what's my definition for it? So my definition for it would be that the extreme rainfall event would need to happen at least 48 hours after heat wave ends, after the final day of the heat wave, which is my criteria for determining if extreme rainfall was associated with the heat wave.
You have a question for me?
That's great. So I was wondering, how much of the change in the heat waves could be due to an expansion of the observation?
So when it comes to the frequency of heat waves, rising due to the observational network. So in this instance, I use Sao Paulo and Maunas as my main cities I was focusing on. I'm also take a look at other cities as well. So in those cities, there were quite a bit of observational areas where they could receive data from. It's only more so in the northwestern portion of Brazil, closer to the Amazon forest. That's where the data does become definitely more sparse. But in the cities I showed, it doesn't seem like there was that the increased amount of observational areas really contributed much to the increasing heat waves, as it's pretty much just been all natural from what I've seen.
You have a question? I have a question. For one of your first figures was you showing like a heat wave and then how some of them had the extreme rainfall afterwards. I was wondering if you looked into why, like what kind of maybe like synoptic conditions were in place when there was that extreme precipitation event afterwards and when there wasn't.
So I haven't taken a look at that specifically, but due to the fact that many of these extreme rainfall events compounding heat waves occur more in the temperate regions of Brazil, where there's a bit more temperature variability, I assume it would be more associated with instability that's associated with cold fronts, let's say. Because of course, during a heat wave, the humidity begins to rise up until the final day of the heat wave. And once the heat wave ends, there needs to be at least some sort of cold pocket. And that cold pocket likely enhances thunderstorm development in the southern portion of the country.
Thank you. Any other questions? Okay, thank you for a great talk.